Hello Legacy students, Marsh here. So today we're going to do operations with radicals. You're going to want that foldable we made in class today, pen or a pencil, and then you're going to also want your thinking caps on today because this is going to be kind of a tough section, but not too bad once we get through with radicals. So guys, here's how you're going to want to label your foldable. First things, operations with radicals is the top flap. Next flap, parts of a radical, and then so on and so forth. You're going to want to have each of those on there, so that way when you flip open you'll be able to tell what you're looking at. Okay? So take a moment, pause the video, write these down on the flaps. Alright, so flip open the top flap and you should see parts of a radical on the bottom. So basically all you did is open that top flap. Now, guys, parts of a radical, we kind of talked a little bit about this, but I want to make sure we have them written down somewhere in a sufficient fashion, okay? So, A is called the index. Now, guys, a lot of the times you're not going to see the index. If there is no index, there is no problem. Assume it is a 2. That would be a square root. So normally, guys, in this class, you're not going to see an index value because we're going to assume it is a 2. In Algebra 2 and possibly even in Geometry, you may see 3s on the outside of that, 4s, 5s. Just be aware that there is a number possibly there, but if there is not, assume there is a 2 there. The sign is what's known as the radical, so be aware of that. And then B, we've called it before, it's called a radicand. So the number under a radical is what's known as a radicand. So that's going to help you with some terminology as we continue along. So now open up your next flap, guys. So you're going to have the parts of a radical is going to fold up. Okay? Now on the back of the parts of a radical part, you're going to want to write the stuff that pops up on the upper hand part. So to add or subtract, you can only combine like radicals. Now what do I mean by a like radical? Like radicals have the same index and the same radicand. So what does that mean? It has the same little number and the same number under the radical. What you're going to want to do is simplify each of the square roots first. That is the first thing. And then you're going to be able to combine like radicals. So to combine like radicals, you're going to add the numbers in the front and you're going to keep the same radicands. So basically the square root number, the number under the square root, is not going to change at all. Let's try a couple of examples here. So go ahead and write these couple of examples down in your foldable before I continue. Alright, so let's break down. I need to get like radicals. Notice, guys, they both have the same index. They both have a little 2 in the back there. But they do not have the same radicand. So I'm going to simplify both of them. Now, 3 cannot be simplified, right? There is no number, no perfect square that I can factor or divide out of 3. But I can do 12. So that'd be square root of 4 and square root of 3, right? So I can make this 2 square roots of 3 right there. Now notice, guys, I have like radicals, right? So all I'm going to do is subtract the numbers in the front. So 5 minus 2, that is 3 square roots of 3. So 5 square roots of 3 minus the square root of 12 is 3 square roots of 3. Something to be aware of. Not too bad, right? You just need to simplify the square roots, both of them or one of them, depending on what you need to do, and then you can subtract the numbers in the front. The radicands, or what's under the radical, does not change at all. Because basically what you're doing is I have 5 square roots of 3 and I'm going to subtract 2 square roots of 3. So I have 3 square roots of 3 left. Let's try example 2. So 4 square roots of 7 plus 2 times the square root of 28. Notice, guys, 7 does not have a perfect square to come out, so let's just leave him. But I do have 28. And I bet 28 has a perfect square. What about 4 and 7? So square root of 4... square root of 7, right? So this would be 2 square roots of 7. But notice, guys, there was originally a 2 out here. So this is technically 2 times 2 square roots of 7, because 2 square roots of 7 is square root of 28. So I would have 4 times the square root of 7, and I can add on 4 square roots of 7. So now, like radicals. No worries now. Let's add. 4 plus 4, 8 times the square root of 7, or 8 square roots of 7. Alright, 5 times the square root of 12 minus 3 times the square root of 27. Notice, guys, 12. 12 has a perfect square, so let's simplify. So that'd be 4 and 3, so 2 square roots of 3. Notice, guys, though, this 5 has to come too, so this would be 10 square roots of 3 right there. Let's break down 27. That's 9 and 3. So this would be 3 times the square root of 3. But notice, guys, we did have this 3 out front. So it would be 3 times 3. 9. We're subtracting. So 10 square roots of 3 minus 9 square roots of 3. That is 1 square root of 3 left behind. Adding and subtracting is not too bad, guys. You just need to make sure that you have like radicals. So you need to use your simplification of radical knowledge that we have recently gained to help us add or subtract them. Alright, what about multiplication? Multiplication is, you can only multiply if your radicals have the same index. In our case, in this class, all of them will have the same index. Then we're going to follow these steps. We're going to multiply the numbers outside the radicals. We're going to multiply the numbers under the radicals, aka the radicands. And then we're going to simplify, if we can. So I got square root of 3 times the square root of 3. That is square root of 9, right? Because we're going to multiply the numbers underneath. Now, technically, I'd multiply by 1s on the outside. That's why I didn't do it. Square root of 9, let's simplify. That is just 3, right? Square root of 9 is 3. Now, this one has a little bit more to him. Let's multiply the numbers outside, multiply the numbers inside. So, 2 times 4 is 8. 12 times 15 is 180. What can I divide out of 180? Let's do, I know 9 can go in there. And 9 times 20 would give me 180, right? Square root of 9 is 3, but square root of 20, I can take out a 4. I can divide a 4 out. So I'll have 3 times 2, which is 6 square roots of 5. So technically, guys, I have 8 times 6 square roots of 5, because this 8 was staying out there, right? Because we got that 2 times 4. Well, we multiply that, we'd have 48 square root of 5. Alright, let's try these ones. I need to distribute, it looks like. So if I distribute the square root of 3, square root of 3 times 3, guys. Now, you cannot multiply these two together ultimately because this guy does not have a radical. So we'd go 1 times 3, so that'd be 3, and then square root of 3 times nothing, which is basically the square root of 3. So this would be 3 square roots of 3. Okay? Plus, square root of 3 times the square root of 6. We can multiply the numbers inside or under the radical, so that'd be square root of 18. Now, 18. He simplifies. Let's break them down. 9, 2. So I can make this, if I rewrite the first part, this would be plus 3 square roots of 2. Right? Now you're probably saying, Marsh, we can combine that with adding. Careful. They are not like radicals. This one has a square root of 3. This one has a square root of 2. Not like radicals. Can't do that. No, no, no. Don't you dare. Don't try. Okay. Those can't be simplified. Now, what about when we have two binomials multiplied by each other? So this is when we're either A, when we use the box, or B, when we FOIL. I'm going to multiply using FOIL. You could try it with the box as well if you want. So it'd be 3 times 3, 9. 3 times negative 4 square roots of 3. So that'd be 12 square roots of 3, right? Because 3 times 4, nothing inside the radical, so it's just going to come along. Now let's multiply this square root of 3 in. So it'd be 3 square roots of 3. And negative 4 square roots of 9, because I'm going to multiply the 2 outside, so that'd be 1 times negative 4, which is negative 4. Square root of 3 times the square root of 3 is the square root of 9. Now, we got to do some simplification here. I see I have like radicals right here, so let's combine that. I have 9 minus 9 square root of 3. Square root of 9 is 3 right here, so I technically have minus 4 times 3. So I have 9 minus 9 square roots of 3 minus 12, right? Negative 4 times 3. So this is technically 9 minus 12, negative 3, minus 9 square roots of 3 for my final answer. What about division? So guys, division is a little different. You're normally going to see 2 radicals stacked on top of each other, or you're going to have to see a fraction inside a big radical. So very first thing, guys, we can divide radicals if they have the same index, just like multiplication. And since we're in Algebra 1 only, we're just going to see things with the same index, because we're only looking at square roots. You're going to want to replace the small radicals with one large radical. So what that actually means is if you have 2 little radicals stacked on top of each other, you can make them in a fraction under one big radical. We're going to simplify the fraction that is resulted under that radical. Then we're going to rewrite with small radicals again on the top and bottom if it's needed. Sometimes it simplifies using that. You're going to simplify the radicals if possible. Make sure everything's in simplest terms. That's going to be one big thing that we're going to look at. And then you're going to rationalize the denominator if necessary. Now, notice, guys, the next tab on our foldable, rationalizing the denominator. We're going to get to that. Normally, in our class, we're not going to have to do that. We're just going to deal with kind of simpler division problems. However, that is something to be aware of. So, example 1, I have square root of 8 divided by square root of 2. So what I'm going to do, guys, is I right now have 2 small radicals, and I'm going to make them under one big radical. So technically, I'm going to make it square root of 8 divided by 2. So what I did is took the 2 baby radicals and made one big radical. So then I got the square root of 4, right? 8 divided by 2, that's 4. Well, square root of 4 is 2. So square root of 8 divided by square root of 2 is just plain old 2. I don't have to do anything further with that. I'm done. Now, let's look at this one. Look, I'm under one big radical. So, let's follow our steps here. I'm under one big radical. Let's reduce the fraction under the radicals. So 4 over 36, that is the same as 1 over 9, right? 1 over 9. Now, let's write with small radicals again. So, I'm going to get square root of 1 over square root of 9. Let's simplify. Square root of 1, 1. Square root of 9, 3. 1/3 is my answer. And the final tab, rationalizing the denominator. You're probably saying, Marsh, that sounds scary. Well, all it is saying is you need to have not a perfect square, or not a square root under in the denominator. Radicals cannot be left in the denominator. It's etiquette, if you want to consider it for math. It's frowned upon when you have a radical in the denominator. So we're going to learn how to take care of it. So ultimately what you're going to do is you're going to multiply the numerator and denominator by the radical in the denominator. Because ultimately we'd be multiplying by, let's say, the square root of 3 divided by the square root of 3, which is technically just 1. And we can multiply anything by 1. We'll get the same number, right? So it doesn't really matter that we are doing this. Ultimately, all we're using is rewriting. So what I'm going to do is multiply the top and the bottom by the radical in the denominator. So I'm going to multiply the top and the bottom by the square root of 2, which is just 1. So all I'm doing is multiplying by 1. So what I'm going to do is multiply the numerators, multiply the denominators. So 8 times square root of 2 is 8 square root of 2. Square root of 2 times square root of 2, square root of 4. Well, we can simplify that. So that'd be 8 square root of 2 all over 2. Now, before you move on, notice 8 over 2. That simplifies. So it'd be 4 square root of 2. always watch for that when you rationalize your denominator. Usually at the end of that, you will find that it will simplify further. So be very careful with that. Let's try example 2 here. So let's multiply the top and the bottom by the square root of 3. So my numerator will be 3 square roots of 3. Square root of 3 times the square root of 3 is the square root of 9, which is just 3. Looks like we can simplify, so 1 square root of 3 for my final answer of that one. Not too bad, right? We're plugging along. It's not too bad. Just multiply the numerator and denominator. So, multiply by square root of 5. Gotta get rid of that square root of 5 down there. Now, if you notice, guys, we've been getting like 2, 3. It's when it was underneath the radical. Let's see if that happens here. So I'll get 15 square roots of 5 over square root of 25. We're going to get a 5 down there. That kind of makes sense, though. If I square root of 5 times the square root of 5, technically that's the square root of 5 squared, which is just 5. So that actually will always happen, guys. If you multiply the square root times himself, you are just going to get the number under the radical. Something to keep in mind. Maybe simplify yourself a couple of steps. 15 over 5 is 3. And that's the end of this video. See you later, Sabers.